Hey everybody, it's your friendly graduate assistant, and today we're going to talk a little bit about the normal curve. Now, beginning statistics students see this and tend to panic. There's no reason to panic whatsoever. Once you stop thinking about it, it's actually really easy. Let's first start out with an example of a circle. Okay, everybody's done this before. I mean, back in grade school, elementary school, you cut a circle in half, and you got 50%. Cut it the other way, and you have quarters. So it's 25%, 25%, and so on. 25, 25. Everybody knows that. But what happens if you take a circle, or an egg shape in that case, cut it down the middle? Obviously you got 25%, or 50%, excuse me. But what if you do this? Well, I'm not sure. What if you do that? Well, I'm not sure. Those are different percentages. Can't we just stick with this one? It's way easier. So that's basically something to keep in mind when we're talking about the normal curve. It's basically just a way to redivide a circle. It's nothing to panic about whatsoever. So let's go ahead and get right into it. Now, most of the numbers that we're going to be using today here in this lesson, these are just approximations. If you ever pull up the actual normal curve distribution chart, you'll get angry and, oh, but it says, 34.1%. You're right, this is just approximations. And approximations with a normal curve, this is fine just to understand what's going on here, what you're starting off with. So first, let's start and take for granted that this curve is normal, even though it's a little messed up right here. And we have our mu, our mean, right down the middle. Now, we talked last time about standard deviation. Okay, we've got our standard deviation right there. And in a normal curve, when you don't have any numbers listed, you commonly have one standard deviation, or two standard deviations. So I'm going to draw those in right here. It doesn't matter where the numbers actually are. It's just the theory behind the thing. So we have -1 standard deviations and 1 standard deviation. Now when you're doing this, it's easiest to break it up just like we did the circle. This area is roughly, let me do a different color here, 34%. Okay, so when you plot, say, scores on a test, this area right here is 34%. Now what's great about a normal curve is it's equal on each side. So this side as well is about 34%. So together, this area is 68%. Now that's saying, whenever we take scores from a test or any statistical model and plot it on a normal curve, we can assume that roughly 68% of the scores, or whatever we're plotting, fall between one standard deviation right here. Now to make it a little more confusing, if we go up to 2 standard deviations, so we have -2 standard deviations, and we have +2 standard deviations. These right here, let me get a new color, are roughly 13.5%. So that means, 13.5% fall between 1 standard deviation to 2 standard deviations. Now, if you, say, ask the question of this right here, if you have a question of what percentage of scores falls between 2 standard deviations, you would add up 13.5 plus 13.5 plus 34 plus 34. Let me pull out my trusty calculator here. What do we got? 13.5 plus 13.5 plus 34 plus 34. So you've got, wow, 95%. So 95% of our scores falls within 2 standard deviations. Now let's take it one last step right here and say that these little tiny wings right here, 2.5% of scores falls 2 standard deviations or higher. So if we actually look at this complete plot, we come up with 100%. So we have 34 plus 34, that's 68%. If we add in up to 2 standard deviations, that's 95. If we add in our little wings, that's 100. Now, all you have to do to remember this stuff is remember these percentages: 34, 13.5, 2.5. And if you get a question, I'll move up top right here, switch color. If you get a question that says, you know, what amount of, what percentage of your scores falls between -2 standard deviations and 1 standard deviation, all you have to do at that point is add 13.5% plus 34% plus 34%. What does that give you right here? 34 plus 34 plus 13.5 equals 81.5. So you can say, if you're asked, you know, what percentage of scores falls in this area right here, you can say 81.5%. So the most important thing that you can get out of this one is just remember 34, and it's equal on each side, 13.5 equal on this side, 2.5 equal on each side. What I find most easy is whenever you're asked a question about the normal curve, actually draw out the normal curve and plot what they're asking. I'm a visual learner. I'm sure many of you are as well. So if it asks, you know, what is the score between 2 standard deviations and -1 standard deviation, you can at that point say, okay, this is the area that I need to figure out right there, and I know that my percentages are 34, 34, and 13.5. So if the question is asking me, what is this right here, I can say, okay, 34 plus 34 plus 13.5, and again, that's 81.5%. So 81.5% of my scores falls between 2 and -1 right there. So one of the tips when you're figuring out things with the normal curve is just to draw a picture. It's one of the most helpful things you can do.